Hi, everyone. I'm Mike Kuentz. I'm a senior solution architect with Amazon Web Services. We have Blayze up here from the University of Pittsburgh Medical Center. I've had the pleasure working with these guys for the last 3 or 4 years. Really, we're going to talk about security, DevOps. There's a healthcare obvious focus here, but you don't have to be a healthcare customer. If you have data you want to secure, these guys have a really good story they're going to tell about that. If the pointer will work. There we go. So security is still a pervasive concern in healthcare and across the board. When I started AWS about 4 years ago, the question I got from every single customer is the cloud secure? I always got that question. I don't get that question as much anymore. I still get it every once in a while. But really what we see is a change, a shift in the way people think, and security is now why people are running to the cloud. You know, we have tons of quotes online. I have a few here you can go and look at. Tom Soderstrom, NASA JPL, is here. He's doing some sessions. He actually has a great quote where he talks about how NASA JPL can use AWS and the security can be done better in AWS than they feel they can do themselves on-prem. This is a really important, powerful statement. And we see this across the industry. We see it in financial services, in healthcare, government, across the board. People are running to the cloud for security good practices. And why is that? So the first piece is around compliance and certification. We have over 50 different global compliance certifications that you can go and take advantage of. Most of these are now actually in the AWS console. So if you want to go take a look at our SOC reports, you can log into the console, go to the section called Artifact, and you can download these. They're independently audited by third parties, so it's not just, we're saying we're doing these things, but we have other people coming in and auditing these as well. Benefiting from our world-class security team, follows the sun 24/7, 365 days out of the year. Always there, always working across the board. And then leveraging the experience of all of our customers, right? So at this point, we like to kind of think of it as a flywheel effect, right? That everybody's going in and we're learning as a group, we're getting these economies of scale, so you don't have to trip and fall on any of these individual security compliance pieces that you're worried about. We have customers that are going through and have already gone down this path, so you can go and actually use that experience. We have a deep set of security controls that you can go through and use, from networking, standard things like network ACLs, firewall rules, we call them security groups for stateful access. Identity and access management, so you can use the AWS tools, you can federate to your Active Directory system, Shibboleth, multiple other providers. Okta's here, they have a great solution on identity and compliance that you can go through and use. And then encryption. We have a lot of services where encryption is free or near free. We want you to encrypt your data, so much so that we make it easy and free or cheap to do so in many cases. So when you look at storage in S3, our simple storage service, you can just go through, click the box, and say everything is now encrypted at rest. And then on compliance, it's tools which Blayze will talk about, CloudTrail, Config, where we can actually go and audit what's happening in your AWS account. So a user logs in and they create an EC2 instance, that's all going to be logged. So you can actually now go to a point in time and look and see what happened last Tuesday. Joe logged in and created an EC2 instance, or whatever the case may be. And you can go and keep and retain those as long as your organizational policy dictates. So if you need to keep the logs for 7 years, you can do the same thing in AWS. This quick quote here from Beth Israel Deaconess Medical Center, again, talking about the difficulties of doing this on-prem, not even just from the security compliance piece of it, but the racking and stacking of servers and implementing tools and process. A lot of the good tools and process you have in place today, you can bring with you to the cloud. You don't have to go through and completely rip and replace everything. Those same things you're doing today for incident response and audit and control, you can still do those in AWS. I'm going to talk about the AWS HIPAA program real quick. So it works off a shared responsibility model. If anybody's ever seen our deep dives on security, we talk about the shared responsibility model. The things that AWS delivers, which is the security of the cloud. And what the customer responsibility is security in the cloud. So the easy way I like to talk about this, we can say from hypervisor down is AWS, EC2 instances up is the customer. And it gets gray in some of these areas. We have managed services where we'll go and we'll help and we'll take care of those things. But all of this is clearly defined. So whether you know it or not, everybody in the room has a solution architect like myself that you can reach out to and work with. And we'll be more than happy to work through and show you where these lines are. And we have most of it documented as well. I'm going to talk about a quick start we have, where we have to launch a HIPAA environment in AWS that has about 800 controls listed and defined on what AWS is taking care of and what you, the customer, will still need to take care of. How we go through and align to the HIPAA security rule, we go and we actually go from FedRAMP NIST standards. So we take a look at NIST 853, the moderate baseline and FedRAMP controls, NIST 866, and we align to that. So when you go through and take a look at our services and controls, you can actually go and use these repeatable formats from NIST that you know and are already familiar with. Some of the things with the AWS BAA that customers can go and sign with AWS, all data must be encrypted. All PHI data must be encrypted in transit and at rest. This is important. Bless you. And then a certain set of services that you can use within AWS. Only certain services can store, transmit, or process PHI. This is a couple of them. The full list is available online. We have over 50 services that you can go through. All your standard services, EC2, database services. A lot of our newer services are being onboarded pretty rapidly. The goal here is that every single AWS service will be able to be used for PHI data. So making it work with your existing architectures. Couple call outs here. So, talk about corporate directories, Active Directory, and security controls that you can do. These can map to identity and access management policies. Your virtual machines, you can import them through a process we have to do native EC2, or you'll probably see today VMware on AWS. So if you have a VMware environment and you pretty much want to move that whole thing into AWS, we have a process that you can go through and do. And VMware will actually sign a BAA with you on that VMware on AWS solution now. That's just announced last week. This is the quick start that I referenced. This is specifically for HIPAA, but if you have a NIST 853, 800-171, PCI, we have these quick starts available that you can actually go and launch into your environment. It takes about 30 minutes to get one of these running. It'll give you bastion hosts, an individual environment for production and development, and then there's a security control matrix that comes with it. So you want to go through and look at the individual controls on logging and auditing. We spell those out in detail, and we show you where in CloudTrail this is taking, or remediation config is going through and doing. Blayze is going to talk about that a little bit more here coming up.
Cool. Thank you, Mike. So the University of Pittsburgh Medical Center, we're an integrated healthcare network, and we're focused on both insurance services as well as the hospital and provider side. In addition to that, UPMC's main focus is improving healthcare through innovation. And therefore, we have UPMC Enterprises, and that's where us and our team works. And so what we focus on is making sure that everything that's deployed into the cloud is done in a secure manner that's HIPAA compliant. And we even started with the quick starts, and we're moving from there. So UPMC Enterprises, and just to give a little bit of the backstory first, we started out as multiple groups, and then we want to work toward an overall solution, working toward specific problems in healthcare. So we had the Technology Development Center. We had multiple subsidiary organizations. In addition to that, we had multiple investment centers. Those groups came together in around 2015, and now we work cohesively to accomplish all the same goals in a more efficient manner. So with regards to what we build and the different services that we have at UPMC Enterprises, we have technology solutions which enable translational science. So the technology solutions could be focused on quality and compliance, reducing costs, increasing revenue. But ultimately, what we want to do is make sure that all of our patient data is secure. And that's where our DevOps team comes in. We want to make sure that, one, we're doing things in the most innovative manner possible. And second, we want to make sure that we're doing it in a secure manner every time. So that's where automation comes in. That's where we focus on using AWS. And AWS enables us to progress securely in the most efficient way possible. So with regards to cloud governance at UPMC, it all starts with the fundamentals with regards to policies in our governance department. We don't expand that into, okay, we have one set of on-prem policies and another set of cloud policies. We just extend what we already have, and then the procedures might be different, the guidelines, the standards. And so, there's a lot of content here, but basically, we work with the Cloud Center of Excellence, and we move toward an efficient model where if there's ever an improvement to a procedure or anything like that, we work with them closely so anyone using AWS is doing everything to the best practices which we define. With regards to building the team, some of the things I want to touch on. So our focus areas, we want to focus on rapidly developing, right? But we also want to make sure everything's secure. And these two things butt heads. So whenever we're talking about velocity in the terms of agile and in an agile work environment, one of the things that can't happen is people just saying, no, you can't do that. And so what AWS enables us to do, we're able to work with development teams and say, okay, you can't do that, but you can do it this way. And so we work closely in the software development lifecycle through a process where sometimes we're in the stand-ups with the teams, but we're decoupled so we can scale across multiple projects. To put it into perspective, we have approximately 70 AWS accounts. And so these are individual projects and the different environments of those projects. So one of the most important things I think there is with regards to HIPAA and healthcare is using infrastructure as code. And that's one thing that we really push. So how we do this and the importance of it, so we have auditability and traceability into any changes. In addition to that, we want to make sure that teams are coming to us and we can get them something, say we've already done this thing manually before. We script it out for the second time, the third time, the fourth time, and so on. So just the general team overview. It's really difficult to find people who have a ton of AWS experience, especially in Pittsburgh. So one of the things that we focus on when looking at customers, potential employees, we'll interview them and make sure they have the fundamental IT concepts, because those are the things that really translate over to using AWS and all of its breadth of services. So we'll talk to people who have a security background, a Linux background, programming, operations, and we bring a team together to then put forth sort of the best effort into making sure these things, not just scalable, but with respect to time. So let's say we're developing something and it's a quick proof of concept, and we have a lot of these, and a lot of customers that are moving to AWS also want to push something into the cloud as soon as possible, right? What we focus on is we just want to make sure that down the line, we centralize all of the operations. So 20 years from now, all of the different teams that are potentially working on this have a standard. So they go to one place for logging, they go to one place for central identity management. And that's some of the things I want to touch on with some of the diagrams later on. One of the things that is inevitable, and you're going to come across in your journey into the cloud, is day-to-day operational support. There's no getting around it. It's something that we have to go through every single day, work with the teams. We have a ticketing queue and everything like that. But in addition, we're trying to make progress on our own goals of standardizing. One of the things that Mike touched on is the HIPAA requirements. So the accounts must be flagged as a HIPAA account. We have to make sure that anything that's going to have patient data in there is flagged. Therefore, in the BAA that we have with Amazon, we're able to get alerted before other customers if there is a breach. With regards to all AWS services, they're able to be used as long as they're not transmitting, storing, or processing PHI. And even the HIPAA eligible services, one of the most important things, it's HIPAA eligible. It's not HIPAA compliant. You have to set all the properties that you need to set to make sure it's compliant. In addition to that, it's not just setting properties, making sure it's encrypted at rest. You need to make sure that the operations around it are HIPAA compliant. So with regards to data retention, one of the main things that we have to do, we have to store data for 6 years. This isn't just CloudTrail. This is the applications, the application logs, and everything like that. So some of the overlooked things that we've come across in moving to AWS, not all the services pass the HIPAA eligible state. So a lot of the times AWS will post blogs on exactly how to implement something for a multi-account setup. And that's one of their best practices that they have. However, one of the things that we run into is we're not able to use all of those services with PHI. So we have to be creative in coming up with our own solutions. In addition to that, some of the things we want to centralize, logging, auditing, and with regards to least privilege authorization at multiple levels, this is one thing that we work with teams. We try to enforce this as best possible. So what we have control of is we use Azure Active Directory to authenticate into all of our AWS accounts. So we have that central identity provider for the authentication. With regards to authorization at scale in each of those accounts and people having access to particular resources, that's something where we use CloudFormation in order to create the roles so people can go in and see, okay, I have these roles, we need to make this change, and it's all auditable. It's something that we can go back and say, okay, it changed here by this person, and pretty much say, here's why based on the ticket that they submitted. So one of the things I want to touch on first is sort of what this looks like and what the architecture looks like within a single project. Like Mike was saying, this is based on the NIST standards that they set with Amazon. So we start out with a standard network. We have 3 availability zones within a region, and then we have 3 NATs, so we have redundancy if anything ever goes down. So how we set that up, we have our private subnets all mapped to a single NAT with their own route tables. In addition to that, we use IAM OpsWorks. We modified this because it has a nice UI where you can basically click on a user and say, okay, you have SSH access, meaning they can then go into the private network. So it's the only means to get to any private ports. In addition to that, what we do, and this isn't representative of what's actually deployed because these are all services that are multi-AZ. And we'll deploy multiple things. So we use Kubernetes, and that's how we deploy most of our applications. In addition to that, with regards to translational science, our data scientists have their own VMs. So we have pre-baked images, we have encrypted disks on every single thing, and we control that all, and we audit that all with config. We see whether or not something's compliant or non-compliant. In addition to that, if anything's ever deployed, if people have increased authorization, maybe it's a pre-production account which does not have PHI, we're able to then go in and see, okay, we're getting alerts from guard duty, which is assessing the VPC flow logs, and we're getting a ticket, and we're responding to that and saying, okay, you shouldn't create this as a publicly accessible EC2, and work with them and really train them so they understand exactly what they're doing and why they would do it in a particular way. In addition to this, to touch on Lambda, that's not necessarily a security thing, but inadvertently it is. So a lot of the services that we deploy, we use a Elastic Load Balancer because that's the abstraction of the Kubernetes API. And we deploy Lambda because we have the load balancers which whitelist only, and so we need that Lambda to have a static IP address. Therefore, we need to deploy it within the VPC, otherwise it would have a source IP that comes from Amazon, and that can change and it's dynamic. In addition to all of this, we have VPC endpoints, so we can have private connections into S3 and DynamoDB. While it's not necessarily a security concern, it increases our ability, it decreases cost, and it increases throughput. Some of the things that we deploy whenever we deploy our initial accounts. So we have AWS CloudTrail. That's something, it monitors everything at the account level, as we touched on before. Config Aggregator is a newer tool which we've been leveraging. And what we do, we deploy a standard set of rules. We use CloudFormation stack sets. And it deploys into all of our AWS accounts. If we have a new role, we just add a new one and run it into CloudFormation from a central account, at which point it's then in there. And we can see it from a central dashboard, whether or not all of our resources are compliant or non-compliant. Now, the next step in that is making sure everything's compliant now that everything's tied in. And then lastly, we deploy guard duty into everything. With regards to AWS organizations, we have that feature enabled since we have so many accounts. One of the important things is whenever we're using AWS Shield Advanced, Shield Advanced looks on the surface scary with regards to price. So it's $3,000. But if you're using organizations, you pay that $3,000 per month just one time. You don't pay it for every single account that you have. So it's really a nice solution where you can get reports on any DDoS attacks or anything with regards to that. One of the things that we make sure that we have in all of our CloudFormation scripts is the security groups. We don't want things open to the world. If they are open to the world and if they need to be, say it's a publicly accessible production website, we make sure that it's deployed with AWS WAF. So that will prevent any SQL injection, XML injection, cross-site scripting, and it operates at layer 7. So where that gets complicated with regards to WAF, we say we want to, and where we have to get creative, we want to deploy an ELB from Kubernetes for our service that's running. However, we want to make this publicly accessible and we want to use WAF. So Kubernetes has the restriction in our self-managed version that we have that we need to use an elastic load balancer. We don't really have a choice. And so if that gets deployed, we want to route our Route 53 to the ELB. However, we want to use AWS WAF. Therefore, we need to use CloudFront. And I know it's not in the traditional sense of how we do it. However, it operates at layer 7, whereas we can have the WAF on that. So now we hit another problem as we're going through this. And another example of where we need to get creative and meet. And we have a hindrance in our development process. And what actually happens is you can bypass that CloudFront distribution and get straight to the ELB, and we don't want that to ever happen. So what we had to do, we ended up finding a blog that AWS posts. In doing that and talking to Mike and talking to their support, we have all these resources to then, if we have a specific use case, we can bring it to them. They assess it, they work with us to sort of find those intricate pieces and then solve that problem. And it's been invaluable. We're to a point where we'll be working on something and we might call Mike up maybe two times a year at this point, which is great. He got us in a really nice position. So one thing that he pointed us to, though, is a blog which solves this problem. So we want CloudFront, which has dynamic source IPs that are public, to access our elastic load balancers. So what we had to do is we have a pub subservice. Amazon publishes their list of public IPs too. We have a Lambda which then parses through. It gets all of the IP addresses from what was published, and then it puts them into a tagged security group that Kubernetes owns. And so whenever it does that, it restricts access to only from CloudFront, and then we make the default security group locked down to just the NAT IP. Otherwise, it would be open to the world. And then at that point, CloudFront's the only thing able to then go ingress to the ELB. In addition to this, another thing that we have to focus on is we want to have all of these logs then come into a central S3 bucket or central logging means. And so we have all of our S3 buckets, and I'll touch on this a little bit later, using AWS KMS with a rotating key. Some of the system level security things that we do, we have pre-established AMIs, and yeah, we can just spin something up really quick, or we can just copy that AMI to have an encrypted disk. Then we meet that encrypted at rest requirement. With regards to encryption in transit, there are other things that we have to do to actually work with the teams to make sure that's enforced. So one of the other things we do, we use the DISA technical implementation guide for hardening our operating system. So we use a tool called OpenSCAP, and we take reports of all of our operating systems that we create AMIs for. At that point, we're able to make any exceptions that we need for all of our operating systems. However, we're using Kubernetes with CoreOS. And so whenever we're doing this, we did a self-assessment of CoreOS and how that compares to DISA. And it actually matched up pretty well, where it's a minimalistic operating system intended to only run Docker. And so once we looked at it, we saw, okay, this is actually pretty secure in how we're implementing this. We made any exceptions that we needed and made some improvements to that operating system as well. In addition to this, for that and for RDS, for EC2 and RDS, we have security groups locked down to the minimum required ingress authorization that we need. We have everything deployed into private subnets. Nothing, unless it's intended to be a public service, should be in a public subnet. So we want to make sure that it doesn't have a public IP, and it's in a private space where you have to log in either through the Bastion or through a VPN to get to these resources. And lastly, system logging to CloudWatch logs. I'll touch on this in a second. With MySQL RDS, one of the things and one of the gotchas we found is we can't enforce teams to use SSL to connect for every single session. So how we sort of address this and what we did, anytime we spin it up, and it has a few benefits, we spin up a DML user for the actual application to use, in addition to DDL users for any of the admins. Each of those users require SSL, but you can't do that for the root user. But that actually turned out to be a blessing in disguise. So we don't have to share RDS root passwords. And so if that's not being used for anything, it's not being used for applications, we can just go in if we ever need to do any system maintenance as the DevOps team, and we'll go into there, we'll connect up, we know to use SSL, but we can just reset that password. We don't need to share a password amongst the team. In addition to this, we have S3 buckets. We have sort of what we determined to be our gold standard, which has all the requirements we need. So we use default encryption, and we have a CloudFormation for this to reference for any team that needs to deploy an S3 bucket. In addition to that, if they need to do it programmatically, we tell them, hey, these are the requirements, and you guys have to do this. So it has to have a rotating KMS key with a particular policy. We have system logging to a central S3 bucket. Abstracted from that into the multi-account view, we have a Kibana dashboard that ties into all the different S3 buckets, because you can only log from S3 to an S3 in its local account, at which point then we can audit everything at scale. And then lastly, we are very big on bucket policies. So the first thing we do is we deny deleting the bucket policy, because that would just not make sense not to do that. So in addition, we deny, and S3 is one of those things where you'll see things in the news where people misconfigure these things and everything like that, and that's really the purpose and why we're doing this. But then we deny static website hosting, so that can't happen, in addition to denying HTTP calls, which you can do with some of the SDKs. So I like to think and talk in sequence diagrams, so sorry about the noise here. But really, what we're doing to tie everything back into our central IDP, and we don't want to have a second set of users. We want to have one set of users, and it all authenticates back into the UPMC system. And so that's why we're pulling in Azure Active Directory. So we have our own AAD instance, at which point, anytime we provision a new account, we create an identity provider within that account. And then we have a CloudFormation script which deploys all of our base rules. And then we have CloudFormation templates where we can go in and create any custom rules that we need to. At that point, we go into Azure Active Directory, we assign a user to one of those roles, and then they can access via the CLI or via the UI, just with their ADM credentials. So they would just go to myapps.microsoft.com and log in. They would just click on a tile, and then it uses SAML2 authentication. And then we also have a tool, it's that AWS Azure login, where they can then just say AWS Azure login, specify their profile, log in with their ADM account, and then at that point, they assume the role and then can do any calls specifying the profile that they specified originally. You're not secure if you're not patching. And so this is one of those things for long-term sustainability that initially when you're spinning things up in the cloud that you don't necessarily think of. Maybe you do, but we did not. So one of the things that we implemented, and we still use standard patching procedures for Linux, for Windows, but with regards to CoreOS with sort of clustered computing environments, this is the strategy that we use. So we use Kubernetes, like I was saying. We use a self-managed currently. We did a beta on EKS, which we're intending to move all of our clusters to. However, we have a lot of things in production, so that entire workflow for migrating that entire thing is going to take at least a month. So for actually patching those clusters, though, we'll have the original operating system and then the patched operating system. We'll update the launch configuration to use the new AMI that is encrypted, at which point we then update the launch configuration, or the auto-scaling group to use the new launch configuration. We then scale it up, and then we introduce the nodes into the cluster. Slowly, we migrate some of these services, which are running concurrently, over to the new operating systems, and then we decommission the old ones as we move. That way we have a way to roll back to the previous nodes, and then we can just decommission everything once all of our services are migrated over. So that's really how we do zero downtime OS upgrades without directly impacting the cluster. We never actually have to go onto any of these nodes and make any changes. And that's really the concept of immutable infrastructure. So with regards to release management and how we handle this, a lot of the times whenever we're being audited or we're working with our governance department, they have policies about direct prod access or access to patient data that's in databases. Especially in the cloud, they get kind of concerned if they're not really familiar with using AWS or Azure or anything like that. And so in dev environments, generally, unless it needs to be, we have no PHI, and developers have increased access. So they're able to spin things up manually, they're able to make any changes that they need to, and they're able to say, okay, this is what we want. At which point then, for test environments, for staging environments, we work with them to make sure it's automated and make sure it's secure. So if they're saying, okay, we want to have a specific DynamoDB table, we work with them and work on the CloudFormation and make sure that they have something that can have be deployed into the other environments in parity. For production, we have just-in-time authorization and grant authorization on a need-to-know basis. So with regards to a multi-account view and some of the things that we've had to come up with our own custom solutions to standardize the title. So what this is used for. So all of our system logs can be dumped from an EC2 to its local CloudWatch from its own account. And what we run into is, okay, say we have a general group of support. You know, we're not going to have support for this project, that project, when they're all the same and they're all running in parity. We want them all to be in the same place. And so if they're all dumping to their own CloudWatch, they would have to log into each and every account to do any sort of support. So we want that to be in a central place. But since we have a limit where RDS and EC2 logs just go to its central account, we need to use Kinesis Streams to then subscribe to those AWS CloudWatch logs and then send data into a Lambda function. And the Lambda function parses that data and puts it neatly into a CloudWatch logs group. At that point, we grant access to whoever needs that. So in this case, it would be analysts or engineers who are actually supporting the underlying systems. With regards to the application logs themselves, so since we're using Kubernetes most of the time, we're using something called FluentD. And what FluentD does, it pushes any Kubernetes logs as well as the standard out logs from the containers running on that into S3. So it's aggregating all of these logs and shipping them into there. Every time an object is shipped into S3, we have a CloudWatch event set up to go to an SQSQ. And this is the next phase in this workflow is something where something was generally available, but it wasn't HIPAA compliant, so we couldn't use it for logs. So in this case, if we were to implement this now, we would use Lambda. However, we're running an EC2 running a service which subscribes to that SQSQ. And then what it does, it receives that S3 event and goes and retrieves that log and then places it into CloudWatch logs. So with regards to monitoring and alerting at scale, and this is something that we've just recently ran by Mike, started working with him on, and we're really rolling this out at this point. So we use Atlassian Jira Service Desk for all of our support. So we could alert into Slack, we could alert into anything else really. However, we want to have some sort of workflow after that to make sure, okay, it's resolved, the root cause is assessed, and everything like that. So what we do, we have CloudWatch events and CloudWatch alarms are our primary sources that are sending into the central SNS queue. So each SNS topic applies to a criticality, and the criticalities of the tickets that we receive based on monitored alerts are based on a matrix that we have based on environment and type of alert. So if we have a guard duty one, all of those are critical. So critical wakes us up at night. So we have custom scripts as well. So we have VPN monitoring scripts from on-prem, which then also alert into this grouping. So the SNS queues are all correlated with the criticality that we define. And then we have a Lambda that's associated with each of those. And so what the Lambda does, it subscribes to that SNS queue. And whenever it receives an alert, it parses that and it places it into a ticket in Jira Service Desk, which we then either are awoken or else we have some sort of SLA to address. One thing to touch on here, so that's phase one. Phase one is doing that. Phase two is determining, okay, what's the standard way to actually address these each and every time each individual type of issue comes up. And so phase three, and what we really want to get into, is dynamic incident response. So the first thing is we already have production systems. We want to monitor these things at scale. And we have those in our production systems now. So operationalizing it, and then from there determining, okay, what's a way that we can automate this fix every single time? Is there any human intervention needed? And most of the time it's no. Most of the time we can use tools that we're using, such as Cloud Checker, leverage the API, and actually go out, retrieve like inventory or something like that that we need to actually say, okay, we need to log into a particular account and fix this problem, you know, a port that's open that's identified by a guard duty alert. Some of the honorable mention services, so these are things that we're using that I didn't necessarily elaborate on. We love using AWS Aurora. Some of the benefits that it provides are really great. So we don't get disk-based alerts on this, for example. It scales. However, you have to watch for cost and different things like that. So we also have AWS Direct Connect. And so that's the, sorry about that. That's also the, that's the direct fiber line from our data center into AWS. So we actually have a public virtual interface implemented. So if we're streaming a lot of data into S3 for particular use cases, that's not going over the general, like normal UPMC NAT. Database migration service is a very interesting one. I think we've used it to convert schemas from Oracle to MySQL. I think some development teams have used that. But what we use it for is, say we need a reporting database. And some of the teams will say, okay, I don't want this reporting database to have any PHI. I want it completely de-identified. And so us being concerned about that, we found that the schema conversion tool, what it can do, you have a DMS instance. It connects to the database and to a replica database, both using SSL, at which point it converts the schema and says, okay, I want to drop these particular columns from the table. And as long as it's not a foreign key or a primary key or anything like that, it will drop those and it'll work like a charm, and then they can run any reports on a de-identified database without risking, you know, potential to actually see PHI. One of the ones that we found important in implementing a data pipeline where we're sending probably 6 terabytes a day right now for a use case into the cloud. So we're using KMS to generate data keys and encrypt those keys with the data to send that all into a third-party provider just to make sure it's secure. They're encrypted at rest. They're also on AWS. But then we have a workflow to actually decrypt that actually on whenever it's being processed on their pipeline. Certificate manager. So we use this with ELBs, and we use this with ALBs, different types of load balancers, as well as CloudFront. And it's a free service. We can go in, we can get free certificates that are signed. With Route 53 and Route 53 health checks, that's something we use all the time, especially on our public services. That's one of the things that we tie into our central alerting platform if anything ever goes down. We use Secrets Manager and SSM Parameter Store. One of the things for patching that we want to get into that we're not right now is using SSM for the patching. I see that there's a central way to do that from a single account, and we want to move toward that. In addition to that, we use Glacier storage from S3, so the Glacier tier storage is a lot cheaper, and a lot of the times it's effective in retaining that data for the 6 years that we need. So we'll have S3 lifecycle policies to say, okay, we want this in the more inexpensive storage, and if that's ever needed by some sort of auditor, or if they just need to see that it's there, it's there. Lastly, we've used AWS Snowball countless times at this point. It's becoming a lot less needed for us since we have Direct Connect now. And so that's all the content that I had. So Mike, throw it over to you.
Yeah, so thank you everybody for attending. Hopefully you found this a good informational session. We're gonna stick around over here on the side, answer questions. We have to turn the room over for the next one coming in, and then we'll be out in the hall afterwards as well. So thank you everyone.